Hello everyone, welcome back. Welcome back to the second session on Kubernetes architecture. So it's going to be a mid-senior level session from DevOps portal. Yeah, let me share the screen. In the first session, I think I may remember we went through about the generic overview on clusters, because we just had an overview for the clustering world because there are different kind of clusters. And we got the idea how a Kubernetes cluster becomes different, right? What's the difference in Kubernetes cluster over the others? And we got some terminology on clusters, Kubernetes cluster terminology, basic terminology, right? And about the KubeCon annual conference as well, right? And now today let's start get into the Kubernetes cluster in more details. Actually, prior to start, it is highly recommended to do this hands-on series, right? So I think if you go to the channel, there is one hands-on series which is in the DevOps portal, which is creating the Kubernetes cluster manually. So now what we are trying to do here is do an architectural walkthrough on Kubernetes cluster, right? The theoretical explanation on the architectural components. But prior to that, if you can just complete this series, you can see starts from manually creating a K8 cluster. It's not a beginner session, it's a mid-senior level. That's why CP10. So lesson 1 to lesson 4. So this will let you know how a cluster can be created in a practical way using AWS T3 medium instances. So if you can get that hands-on done prior to this session, it is great, right? So because then you know how the practically things are happening, then it will be easy to understand the theoretical aspect of the Kubernetes cluster. Right. So having said that, let's start. So this is cluster configuration, right? So just to revise you what is being done on that practical, right? You may remember if you have watched that session, right? There was the manual creation of Kubernetes cluster series. You may remember we did these things on all nodes, right? On either in the control plane node and the worker node. So we had to run these things because these tools, kubelet, right? Kubeadmin, kubectl, especially kubeadmin is required in the master node, and kubelet is in worker nodes, and kubectl in both nodes. So likewise, we install these components, and you may remember these IP tables we had to enable on all nodes, right? And the Docker runtime on all nodes, right? So this is common to every node, worker and master. And in the master node, actually, you may remember we had to enable the init, right? Kubeadmin init just to initiate the cluster on the master node. And after that, so we had to you may remember the output of this command had this propice.kube and the configuration files and the config. So we had to execute those things and the permission as well. And again, after that, you may remember we had to deploy a port network, right? I think we ran Calico, even though here is mentioned kubectl YAML, but either is fine, right? And I mean, remember again, prior to this, we had to pull the containers for API server, and also those things were done in the practical. So just to revise, and once the control plan or the master node is initiated, it gives the output how to add the worker node. So you may remember kubeadmin join command, right? So using this join command and the token authentication, certificate authority, and so then the worker node can join to the master node. So that is what we did in that practical. And finally, you may remember we had the 3 nodes up and running. One is master, and we had the 2 worker nodes, right? So not ready is just the initial point. After some time, 1 to 2 minutes time, it becomes ready, right? All right. So that is what we did, right? Just to revise, right? But always advisable to do the hands-on prior to the next slide, because next slide we are going to have a detailed walkthrough on the Kubernetes architecture, right? In theoretical aspect. All right, let's start, right? Okay, so first thing is we will get familiar with the cluster components in bit detail. After that, let's do a walkthrough the process overview, right? How the things are happening step by step within the cluster once the workload deployment requested, how is happening. Right, let's take a look at the components first, right? So this is not a complex cluster, and again, this is production level. I mean, you can have doesn't matter, even at production, one control plane and two worker nodes, it will do it, but it's not the best practice. I have mentioned it, right? We need to make sure the control plane is high availability, right? High available ready, and the worker nodes, enough worker nodes for bear the loads that you are deploying to the application, right? As per the requirement in production, right? So, and again, I need to tell you, this is not a deep dive. This is not a deep dive of the Kubernetes architecture. This is around average mid-level mid-level explanation of the Kubernetes architecture, right? So later, again, we'll be doing a great detail, a deep dive of Kubernetes architecture. But we need to have this understanding first prior to get into the deep end, right? Okay, so the cluster components. So first in the master, right? So in the master, the very important one, the very first component is what? Kube API server. So API server, this is the cluster interface, right? Because any request to the cluster will be taken in from the API server. Now let's say, for example, if you want to deploy application and you want to create a product node, create a resource, create a service resource or whatever, we'll be interacting with the cluster with an external tool like maybe kubectl or maybe Helm chart or whatever deployment method, right? So that client tool, kubectl, will be sending a request for the API server. That's how it's going to be, right? And even if a URL, I mean, if you want to connect to the cluster using a URL, maybe you want to access application, still the request comes to the API server, right? And prior to this, prior to hitting the API server, we may have ingress gateway and load balance and whatever, because the contents within the cluster should be exposed to outside via services, right? So those parts are not addressed here, but those parts will be discussing later, right? But this is internal components of the master server. So the very first thing is Kube API server, which is acting as the gateway or the interface for the cluster. That's what it says. Act as the front end. All right. Then comes the scheduler, right? Scheduler assigns work slot to the nodes. Yeah, exactly. Because now a request will be hitting to the API server. So API server will compile the request, and there are I mean, it will get together with the other things like I think it is coming Cloud Control Manager, and we have Kube Control Manager, because API server alone, it can't process the request. It needs the information from etcd and all. So that we will do in the next slide. But as a component definition, right? Component definition wise, what the scheduler does, scheduler assigns the workloads to the worker node. That's what it does. Right? When the request is being compiled by the API server, it will hand it to the scheduler. Then scheduler will have to work through some logics, right? Selection criteria, what is the best fit node for this particular workload, right? Again, on the deployment itself, we can do customized resource request, right? I mean, we know in the YAML files, we can give best separate or guaranteed, right? Okay. I mean, quality of service. Quality of service can be by default always best separate, or the QoS can be guaranteed. Guaranteed means we are telling for this particular application, for this particular workload, we need this much of resources. We need this much of memory, this much of processing power, likewise. So depending on that request, Kube scheduler has to find a node, right, where it can occupy this workload as per the request coming from the manifest file or from the YAML file, right? So that's what the scheduler do. It will then schedule the workload as per the required resources within one of those worker nodes, scheduler, right? Then come the Cloud Control Manager. Cloud Control Manager will not be always in action, because unless you have maybe if you have seen a managed cluster from one of the cloud provider, definitely this component will be active. Other than that, if you are not interacting with any of the cloud components using the cluster, this component may not be used heavily, right? So if there's a cloud involvement for the cluster, yes, this component will be there. So links the cluster to cloud provider API. So that's why, right? Maybe now there are managed clusters now, like AKs, we know EKs, right? Azure cluster, Amazon cluster, Oracle cluster, GK cluster, Google clusters, like that, right? Okay, so then comes the Kube control manager, which is maintaining the control information, right? And in the control manager, we can see four components, four subcomponents are there, which is a node controller, job controller, endpoint controller, and we have the service accounts and the token controller. Right, so that is one. So we have four subcomponents. In summary, the kube controller mainly taking care about the control information, but as to what's happening in the cluster likewise, right? So that's why the node controller, because it needs to know the node information, whether the node is active, whether the node is communicating properly, whether the node is busy, likewise. And the jobs, yes, what is happening with the scheduler information, what are the jobs which is running on particular nodes, right? Here's the endpoint information, yeah, as per the replica set, because deployment will go to replica, that means multiple ports, right? So whether endpoint is accessible and no, right? And the service accounts, yes, this is very important thing, because if this cluster, I mean, for example, we can link the Kubernetes cluster with Jenkins, right? So how a Jenkins build job is going to be deployed over the Kubernetes cluster. So then the service accounts need to be there, because to establish the authentication between the Jenkins plugin and the Kubernetes cluster. So likewise, and the tokens, right? So tokens, I mean, even to communicate within the cluster, there should be authentication, right? Because when a pod, right, when a pod is going to talk to another pod, still authentication is required, right? And prior to that, to get into the cluster, the API server itself, here's a security gateway, right? The API server needs authentication, proper authentication. So if the tokens are correct, then only it will allow to get into the cluster. So likewise, token also very important, right? All right, so that's the another next one is HCD, right? ETCD, right? So HCD or ETCD, you can say this is the key value we store for all cluster related data. Yeah. Now this is a database kind of a thing for the cluster to store the cluster information, right? So likewise, this control manager is having information, and there should be a place to store, right? As of now, what is the status of this node? As of now, what is the status of kubelet, right? Because kubelet is working in container runtime to deploy the pods, right? So likewise, so all the information, cluster related information, right? Because HCD is not going to maintain the application related database information, right? Because a particular application or deployment may deal with the database information. So that is not there in HCD, right? This is within the cluster. As of now, what is happening, right? And because I mean, for example, it may maintain like a matrix, and you'll have statistics, right? What is happening now, as well as for a continuous period of time, likewise. So HCD is a very critical source. It is known as a key value. Yeah, that is the way it's, I mean, store the information, right? Key value database, right? And like Redis and all, right? Those things. And it is very critical, and we need to maintain this one. We can take backup of this one as well. So HCD, key value store for cluster related data. Yeah, so that is about the master node. So we can take this info from, I think if you go to the web, right? So hold on. Let me reshare it. Yeah, if you go to the Kubernetes documentation, right? Yeah, I think they have explanation for these things, right? Cluster architecture, right? This one. Yeah. Control plane and communication, node and control plane, API server kubelet. Yes. So let's go to this one, overview concepts. So what is Kubernetes? We have, yeah, that is not that. And okay, let's check here. Yeah, Kubernetes components. Yeah, this is the one I want to show you, right? So here in the Kubernetes official documentation itself, right? So they are giving an explanation to the components first. The same thing what I did here. right? So you can if you go through it again, you can see the APIs. What is API server is given here, right? So that is about I am in getting started concept overview, Kubernetes components, right? And API, so you can see the API server is a component of the Kubernetes control plane, exposes the Kubernetes API. So you can see the API server is the front end of the Kubernetes cluster. That's the same thing I was explaining, right? And you can see HCD consistent of high available key value store. Use Kubernetes backend, yeah, for clusters about the data, right? Kubernetes cluster related information, right? If your Kubernetes cluster, you can read that one, see, and mainly used to backend store for all cluster data, cluster related data, right? Key value store, right? Yes, so that is where the cluster related information is maintained. Right? And most of the all of the components actually accessing HCD to get the information, especially the control manager, right? And API server as well. Okay, right. Then the schedule, as I mentioned, control plan component that watches for any newly created port and with no assigned nodes, right? And selects a node and that's right, job scheduler. It will select a node as I explained, and it will try to assign that particular workload to the node, right? And as I mentioned, the control manager, you can see control plane component that run on a control manager process. Logically, each controller is a separate process, but to reduce complexity, yeah, they are all compiled into a single binary here. So that's why the subcomponents I have told explained. So it's same thing is explained in the Kubernetes documentation as well. So you can go through it, and yeah, so that is what the master server component, right? All right, so let's go to the worker nodes components as well, right? And so having understanding the master nodes component, right? So now let's go to the worker nodes component. So in the worker nodes, you're going to have these things, kubelet, right? And I think I have basically explained what is a kubelet is earlier as well. You can see, make sure the containers are running in a pod, right? Yeah. The main functionality of the kubelet actually, once the scheduler needs to run a workload, right? It needs to start a pod, right? So kubelet will undertake of that process, that task. Mainly it will initiate a pod and it makes sure the containers are coming up by linking with the container runtime. So likewise, kubelet. Make sure the containers are, you can see here, right? Containers are running in the pod. That's what kubelet. And kubelet is yeah, mainly on worker nodes, right? We don't need to have kubelet on master node. Yeah. Then the proxy, right? Manages the services. Yeah, kube proxy actually it's like this is mainly involved with the services, right? Manages the services because you know once we deploy the workloads, the pods are going to come and within the cluster. When the pods are up, it's run on a different network, right? It's a pod network. So the external users won't be able to access that one. So that's why we need to expose what is running internally in the cluster to outside using services, right? So when this exposing taking place, there are network routing and the communication need to be take place. So the kube proxy is going to manage that part, right? How a service is going to expose it to outside the cluster, right? Kube proxy. Then have the container runtime, responsible for the for running containers. Yes, I think you may remember we use Docker as a container runtime. So this is all about when a pod is creating, when the pod is created, it needs to pull the images from wherever the container registry or the container repository. So then the image should be executed, then the container should be up and running, right? So container runtime is making sure that containers are running as per the deployed container runtime. You may have CRI, you may have Docker, right? Responsible for running the containers in combination with kubelet actually. Okay. Right, so those are the components in worker nodes mainly, right? So again, we can go back to our documentation. We can check what they are telling for those definitions. You can see node components are there. Kubelet, right? So again, you can see an urge agent that runs on each node in the cluster. It makes sure the containers are running in a pod. So that's what I mentioned, the same thing. And again, further is explained, kubelet takes the set of pod specs, right, that is in the manifest file, right, that are provided through the various mechanisms, ensure that the containers described in those pod specs are running healthy. That's right. So it will make sure the containers are up and running within the pods. Then comes the kube proxy. Kube proxy is a network proxy that runs on each node in your cluster, implementing part of Kubernetes service concept. That's true, because alone the kube proxy is not going to handle the total service, deployment, because it interacts with other components as well. But kube proxy mainly dealing with the networking stuff, routing stuff with related to the service, right? When the service is created. Right, because there are different service type, node port, cluster IP, load balancer, likewise, right? Network rules on the node. Yeah, kube proxy maintains the network rules on the node. Yes, routing stuff. Then the container runtime. The container runtime is a software that is responsible for running containers. So that's what I mentioned. We have Docker, we have others, container, right? CRIO, and any implementation of Kubernetes CRI. That's right. So support several container runtime because not only Docker, right? Others are there. The container runtime is the software that responsible for running containers. Yes. Once the job is assigned by scheduler, kubectl in combination with container runtime need to make sure the containers are up and running within the pods, right? So these are the basic components. You can do add-ons. Understood. Add-ons are always there. You can deploy them as needed, right? So you have it, right? All right. Yes, so that is that about the components, right? So up next, what we have, now we know the definitions of the component, the basic components in the Kubernetes cluster, right? Up next is the walkthrough on how these components interact each other. How these components interact each other. So that we will do in the next session. Otherwise, this is taking long time. All right, let me meet you soon again with the next session. Okay, have a great time. Bye. Bye.